Hi ladies, Mr. O'Sullivan. Today is a edPuzzle lesson. We are beginning a new unit, unit number 8, where we look at 3D geometry. This is actually a very important SAT skill next year because you need to know how to find the area of figures, volume of figures, and it actually pops up each year. And you don't go over in Algebra 2, so we need to go over it now. So before we even go into the unit, we're actually going to do some middle school material because in order to do the harder questions of this unit, we need to basically make sure we understand the basics. So what we're going to be doing today is we're going to be learning how to find the area of basically any polygon. So today's learning target is I can apply the area formula to calculate the area of a polygon. And when I say polygon, I basically mean any shape. So before we go into what area is, it's the size of a surface. It's the amount of space inside the boundary of a flat 2D object, such as a triangle or a circle. You can even think of other shapes. And it's measured in square units. So whenever you talk about area, your units are going to be squared. So I have centimeter squared, millimeter squared, unit squared, feet squared. Any type of length would be squared. Okay, now let's look at our figures. We have a triangle. This is a triangle. Right here, this is a triangle. We need to know what the shapes are. The area formula for a triangle can be written in two ways. We can write it as area equals 1/2 the base times the height, or we can write it as area equals BH over 2. I actually prefer this way right here. It just looks nicer to me. Number 2. We have the parallelogram, and this works for rectangles, rhombi, and squares as well. So when we talk about this, our area formula is just going to be base times height or length times width. That's for the rectangle. The length times width we typically use with the rectangle. But just to give you a heads up, when we look at our height, we're talking about this as our height. We're not talking about the outside as our height. This is not our height right here. This is our height. This is our height because you get measured vertical. You don't get measured slanted. The trapezoid, we have base 1, base 2, and then if you look in here, we have our height. The area formula for a trapezoid can be written in two ways as well. It can be written as area equals 1/2 B1 plus B2 times your height. I actually write it a different way. I write it like this. Area equals H times B1 plus B2 all over 2. And these are your bases. This is your height. You just make the substitutions. So when I say B1 and B2, I'm talking about base 1 and base 2. So now let's go on to the square. There are 3 ways to write your formula for the square. I can write it as base times height. I can also write it as S times S. Or I can just write it as S squared, where I basically take my side and square it, because I know all the sides of a square are congruent. Okay, let's do some practice problems where we actually learn how to find the area. In this image right here, we have a triangle. So this is a triangle. So when we want to find the area of a triangle, we go back up here and we look, and our area formula is base times height over 2. So I'm going to write in base times height over 2. Now I'm going to make my substitutions. My base is 12. My height is 5.2. And now I'm going to multiply those two and divide by 2. So I do 12 times 5.2, which is 62.4, and then I divide by 2, which gives me 31.2. So my area is 31.2 inches squared. And that's my final answer. Now, the reason why I'm putting inches squared is because remember, we said area is measured in units squared. Now let's go on to this example where we have a rectangle. If we look above, we know the rectangle area is length times width or base times height. You can write it either way. I'm not going to penalize you. So if I look, my base is 6, my height is 3. So I'm going to be doing 6 times 3. What's 6 times 3? 18. So my area is 18 miles squared. Now let's go on to this example. In this image right here, we have a trapezoid. If we go above, we know our trapezoid formula is going to be, I'm going to use this one because that's the one I prefer. H times B1 plus B2 divided by 2. So let's do that. So area equals H times B1 plus B2 over 2. So I look at my height. My height is 7.1. Now I do my base 1 plus base 2, so 5.1 plus 10.9. And I divide by 2. And I just type this into my calculator. I type this into my calculator exactly as it's written. So I'm going to do that right now. So 7.1 times 5.1 plus 10.9 divide by 2, and I get 56.8. So I get my area to be equal to 56.8 centimeters squared. And that's your final answer. Let's go on to the next example. If we look at this one, I have a parallelogram. So when I want to find the area of a parallelogram, I go back up and I know my area rule is base times height. So I'm going to write in area equals base times height. If I look, my base is 9. And my height is always going to be this number right here because look, that's your vertical length. We're not doing our slant length. We're always doing our vertical length. So we're going to plug in an 8.4. We type that into our calculator, and we get 75.6 centimeters squared. Ooh, let's go on to some tricky ones. So these are a little more challenging. If I look, these are going to require Pythagorean theorem. This is a square and this is a right triangle with two sides congruent. So if I look at this one, I know that I don't know what my side length is, so I'm going to put an X here. So what this would become is a Pythagorean theorem problem because I have a right angle and a right angle, so I can do x squared plus x squared equals 7 radical 2 squared. Because the thing is, in order to find my area, I need to know what my side length is, all right? So x squared plus x squared is 2x squared. 7 radical 2 squared is going to be 98. Divide both sides by 2. Get x squared is equal to 49. How do I get rid of a square? I take the square root. And I get x is equal to 7. So now that I know x is equal to 7, I'm going to go back into my image and put it back in for x. Now we have a square, so we know our area formula is side squared. So I get area equals 7 squared. So area is equal to 49 centimeters squared. And that's your final answer. Now let's go on to this question. This is the exact same process where we need to solve for our missing side length. So let's go ahead and solve for our missing side length. I'm going to actually just move this work here. No, I'll just do it here. Okay, so I'm not going to use x this time. I'm going to use y this time. So I'm going to do y and y. The reason why I'm putting a y and a y is because those sides are congruent. They both have one tick mark. So Pythagorean theorem says a squared plus b squared equals c squared. So I can do y squared plus y squared equals 12 squared. So I get 2y squared equals 144. Divide by 2. I get y squared is equal to 72. Take the square root of both sides, take the square root. I get y is equal to, well, I need to break apart a radical 72. So I'm going to go down here and just break apart my radical 72. I can break apart 72 into 2 and 36, 6 and 6, 2 and 3, 2 and 3. And now I write all those numbers under a radical, so I'd write 2 times 2. Oop, not the 6s, my apologies. So I write 2 times 2 times 3 times 2 times 3. Now I have to ask myself, do I have any doubles? I do. I got a double 2, so that becomes a single on the outside. I got a double 3, so that becomes a single on the outside. What's 2 times 3? 6, and then radical 2. So I know that my side lengths of this triangle are 6 radical 2. So now I can do my area. We know this is a triangle, so the area is equal to base times height divided by 2. So this is my base, this is my height. So I'm going to do area equals 6 radical 2 times 6 radical 2 all over 2. And I can just type that into my calculator. When I type that into my calculator, I get 36 inches squared. And that's your final answer. Okay, let's go on to the next problem. In this question, find the smaller base of a trapezoid whose larger base is 7.9, the height is 3.7, and the area is 20.7. Round your answer to the nearest tenth of a meter. So with this question, first thing we need to do is we got to draw a trapezoid. Again, Mr. O'Sullivan's not an artist, he is a math teacher. It actually isn't looking that bad, I'm not gonna lie. I'm pretty happy with it. Okay, that's actually not that bad, I'm pretty happy. So I know that my larger base is 7.9, so I'm gonna put my 7.9 right here. I know that my height is 3.7, so I'm gonna draw in my height. And my area is 20.7. So I want to find out what my other base is, so I'm going to put an X here. If we look back, we know the area formula for a trapezoid is H times B1 plus B2 over 2. So I'm going to write this down. Area equals H times B1 plus B2 divided by 2. We're now going to make our substitutions. We know our height's 3.7, and we know our base 1 is 7.9, and we know base 2 is X. And we know our area is 20.7. So I'm going to do 20.7 equals my height of 3.7 times base 1 plus base 2, so 7.9 plus X divided by 2. First thing I'm going to do, you ready? How do I get rid of a divide by 2? I multiply by 2. So I'm going to multiply both sides of my equation by 2. So my 2's cancel right here. 2 times 20.7 is 41.4. So I get 41.4 equals 3.7 times 7.9 plus X. Now, whenever I have a number on the outside of my parentheses, I have to distribute. So I distribute. So I get 41.4 equals 3.7 times 7.9 plus 3.7x. I got to get rid of my 29.23, so I'm going to subtract 29.23 from both sides of my equation. So 41.4 minus 29.23 is 12.17. And then I'm going to divide by 3.7 on both sides. So I get x is equal to 3.289189189, and it says I want to round to the nearest tenth of a meter. So I go out 1 decimal, look to the right, 5 are high, go to the sky. That's definitely higher than a 5, so my final answer is going to be 3.3 meters. And that's your final answer. Okay, and that's it for today. There is no Delta Math, it's just the edPuzzle because it was a very long one. If you have any questions, email myself or Ms. Colorundo. Have a great day, ladies.